Okay, hello everyone. This is Zhenyuan Xia from Chalmers from Industrial Material Science Department. And currently we have a joint project in HSB Living Lab related to the water purification according to a new filter technique based on graphene. So it's really my pleasure to have this record to show you uh, what's the main purpose of this project and currently what's going on from the starting point. So basically, our target is focus on water purification. And you already know that we are using everyday water from drinking it and from shower, from washing everything. We cannot live without water. It's very important. However, there's water contamination also connected with our living life. So once you are using it, once the water is flushed away, actually it's potentially also contaminating our environment. It's not like what we thought. The pollution is like this dirty, dark water that go into the rivers or the lakes from industry. But actually, there's a lot of things behind it. We cannot see it, but still contaminating our ecosystem. For example, right now, we are using a lot of the pharmaceuticals and personal care products. These things, later I will show you, we call it PCCP, contains lists of thousands of chemicals inside. And what we use now every day because of the COVID pandemic is the hand washer. Actually, in some of the hand washer, not all of them, they include some organic chemicals like triclosan and phenols, which are used to kill bacteria. And we also use shampoo and conditioner every day. They also include dyes, the parabens, surfactants, and in summertime, when you go outside, I guess you will use sunscreen, but this sunscreen, it also includes UV absorbers, the agents including benzophenolanes. And also we will use other cosmetics. They will contain, they potentially include, for example, PFAS, BHA, and benzonates, these kind of chemicals. And maybe you also use some pharmaceutical medicines, and also these pharmaceutical chemicals, they are quite resistant to the environment and could be harmful to our water system. And actually, these things, as I tell you before, the pharmaceutical and personal care products, PCCPs, and some of them are listed here, the pharmaceutical things, hand washer, and cosmetics, sunscreen. With these chemicals, they are already listed as emergency organic contaminants by EU. And it's really quite emerging issue related to the environment. And these things, together with other chemicals, could be exist, which, for example, pesticides, heavy metals, and bacteria. In together, they are a threat for our clean water. And there's no current technique is perfectly that is available to remove these chemicals efficiently. And also in EU, they're always updating the drinking water directives. The rules related to these emergency chemicals is always updated because we never know which chemical could potentially threaten our environment, but always new chemicals has been used in industry for personal care things. And this is just to show you that how our contaminants, organic contaminants, can be spread in the environment and then go back to the ecosystem. And you might know that since these chemicals, they cannot be efficiently be biodegradable, and the incomplete assumption by animals and humans will make this bioaccumulable up to the food chain. And in the end, it will reach a dangerous level for both human bodies and our very weak ecosystem. And the worst thing is these kinds of chemicals are highly resistant even to the most advanced water treatment technologies. So this is the real concern of us, that how can we find a way to efficiently remove it. And as you know that our government, including the EU, is always try to monitor these kind of contamination issues. And they have the concern mainly on the safety of new chemicals, monitoring of the chemicals, and accessibility to treat it well. So we really need new technology for the removal of organic contaminants. And as I said, that the EU government is updating the contaminants. For example, 3 years ago, they have added 18 new or revised parameters, including new chemicals that could potentially threaten our environment. And I think it should be always updated because the chemicals, especially organic chemicals, the concern about their toxicity and the environment threat is really, really high need and for both the government and company, and also closely related to our health. As I say that there's no technique which is 100% efficient to remove of the contaminants. Let's see how people did, especially to the drinking water. So you can have a small setup to purify it. And this is the normal way that you can buy it from the market. That they use the multiple step processing technique. And the most important step is the active carbon and the reverse osmosis, or RO. In case of active carbon, you cannot avoid the bacterial growth. So you have to change it very frequently. And there's another bad thing from the preparation of active carbon. People usually use the shell of the coconut and they burn it. And after carbonization, they go to the active carbon. But the process to produce the coconut itself is an environmental threat. And for the reverse osmosis, RO, it's a very good technique, widely used, but they can only purify or passing the water almost 0.5%. There will be around 40 to 65% water rejection, and you have to use the pump to pushing the water passing by, so there's energy consumption. And also you have the requirement for pre and post treatment to take care of this filter. So both techniques are not so good. Then we are looking for new material in the membrane filtration. And one of the most promising is graphene. And I can show you that you might know this history about graphene. It was recognized, especially it's famous from the two Nobel physics winner, who is Andrew Gain and Constant Novosel, that they discovered graphene actually is in 2004, that they found that this graphene is bring a groundbreaking experience related to 2D materials. So it's the world's first discovered materials of 2D, two-dimensional scale. And actually, graphene is made by the 6 carbon atoms with these honeycomb shapes connect with each other, but it's only one layer. So it's a very thin material. And there's different way to obtain this kind of thin material. And one way we quite used is the chemical way. So you use harsh chemical oxidation agents, and then you can expand it, integrate it, and extract it. In the end, you will get this oxidized graphene. We call it graphene oxide. It's very similar to the pristine graphene, but it also has a lot of oxygen functional groups on the surface. And this kind of graphene is very interesting because first, it's easy to produce. And second, this graphene is showing the high potential, especially in water purification, because it has a large aspect ratio and it's hydrophilic, and also it can maintain the high surface area during the processing. So it's a very good starting material for us to use in water purification. And this is the experiments that previously, in cooperation with our partners from Italian National Research Council, and also with the water filtration supply, which is a company we call Medica, that they have used the combination of graphene with polymer. In this case, it's a polysulfone, and produce different shapes like granule powder and hollow filters, and assemble them inside the container, then passing the water through. Then this monitor the efficiency of this kind of filter in organic contaminant removal. And for example, this is one of the recent work that to monitor the removal of these 2 chemical, which is the antibiotics, OFL, and the ciprofloxacin. And also it's very efficient to remove organic dye. This is the rhodamine B, widely used the textile dye. And it showed a very good efficiency for remove chemicals. With the increasing of the graphene oxide amount, we have higher removal related to the chemicals. And actually, it's not only limited in these chemicals, it could be also useful even to remove other chemicals. And currently, we are also trying to study the removal efficiency of PFAS, which is very, very harsh organic material, which is resistant to all the how to say, it's resistant to the environment and exists everywhere. So if we can use graphene also in PFAS treatment, it would be excellent material for future. And actually, the removal of graphene, it has different mechanisms to expand them, but simplest one is just because the membrane is has a very small polar structure, so a lot of chemicals that will be blocked. Only water is available to penetrate, and in this way, that graphene can be used as a good substrate for water purification. And this is a very short cartoon to show you that the filtration of water, but blocking of other chemicals. And on the right side is currently, except us, there's also other companies that are trying to provide this kind of graphene filter for potable drinking water treatment. And that's all the basic things and backgrounds about the water purification. And currently, what we are doing here in Chalmers is we are trying to scale up. We produce a large filter, similar like what you see here. And then we use this one in the HSB Living Lab to monitor the gray water from showers to see that how we can remove the organic contaminants from the shower from gray water. And we are targeting for different chemicals. So most of them should be, we will fix on surfactants to see that the efficiency of organic removals by our system. And I prepared a very short video to show you the whole setup and the idea. And since we just started recently, so we are still collecting the data. And I hope in short future, we will have more clear understanding about the organic removal efficiency related to our material. So now let's go to the video and see the whole setups and ideas. So you already see that the setup inside the HSB Living Lab building, that we have this graphene filter installed inside. Actually, is one is the graphene filter, one is the commercial filter. We are comparing with these different filters, and this is in cooperation with one of the company here in Gothenburg with Great because they have preset all the pipes, and then we are using the last part to connect with our graphene filter. And the project is still ongoing, and I hope that in the end of the project, we will have a clear understanding of the removal efficiency, especially related to the surfactants, because right now we monitor a lot of surfactants exist in the gray water system. So I hope you enjoyed the talk with me, and thank you for your watching. And following is my information. And if you think interesting and you want to ask me any question, just send me by email. Okay, we should enjoy the HSB Living Lab days.